In this lecture, we're going to talk about the sum of an arithmetic sequence in its general form. An arithmetic sequence is defined as the following. We start with a number a constant a, and the sequence follows a pattern that the next term always equal a constant, in here d, plus the previous term. So if you start with a, the next term is a plus d. The next term is a plus 2d. The next term will be a plus 3d. As you see that the difference between the next term minus the current term is always d. And such a sequence is called an arithmetic sequence. This class will be a bit of abstract, especially for fourth graders or fifth graders. I will try to make as concrete as possible, and I think that you can follow this easily. So let's look at some examples of such an arithmetic sequence. Example 1. If a equals 1, d equals 1. Now the sequence goes 1, a plus d is a 2, a plus 2d is a 3, 4, okay, and this is obviously just the numbers, the sequence of the counting numbers. And again, another example, when a equals 1, d equals 3, the sequence goes like 1, 4, 7, every time it's adding a d, which is 3. So 10, 13, which is the sequence that we talked about in the last lecture about the sum of a special arithmetic sequence. And why we limit ourselves to a as a integer and d as integer, actually both are positive integer. Let's look at example a is start with a 1, but d equals minus 3. So it goes like 1, next term will be 1 minus 3 is a minus 2, minus 2 plus minus 3, so minus 5. Now basically every term, next term equals the previous term minus 3 or plus negative 3. Okay? So that's a sequence, also an arithmetic sequence. And we can do a is, let's say, start with, I don't know, 1 or 3. D equals 1/2. So what's that sequence? So start with 1/3. The next one will be 1/3 plus 1/2, which of course is 5 or 6. The next term is 1/3 plus 2 times 1/2 is a 1. And 1/3 plus 3 over 2, and so on. Again, the difference is a constant, and this falls into the definition of arithmetic sequence. Okay? And if you're given the sequence, how you find the a and d? Well, the a is just the first term by definition. The d will be the difference between any two neighboring terms. For example, you can take the first one and second one and take the difference, you get a d out. So this minus this is 1/2. Okay? So this representation and the sequence, you can get one from the other very easily. Now this lecture, we concern ourselves to calculate the sum of arithmetic sequence in its general form. So the question we're asking is how we calculate this sum s equals a, the first term, plus a plus d, which is the second term, plus a plus 2d, plus all the way to a plus 97d, which is which term? Think about it. This is the 98th term because we start with a plus 0d. So which which term of this is going to be this number plus 1? Because the first term is plus 0d. The second term is plus 1d. So the 98th term is plus 97d. And the 99 term will be plus 98d. And the 100 term is a plus 99d. Okay? To calculate this term, there are actually two ways of doing it. I'm going to show you, let's show you both ways. The first way is using the same technique as in the last lecture about this special sequence. Remember how we do that sum? We do the sum using this a plus a plus a plus d. The sequence, represent terms in its increasing order. And then we calculate the sum using its reversing order. So we start with the 100th term, which is a plus 99d. And the 99th term will be a plus 98d and plus a plus 97d. So we're basically taking the last term and walk backward and doing that sum. So here, the last three terms will be a plus 2d plus a plus d and plus a. Okay, and these two sums are the same based on the property that sum is commutative, so it does not really matter about orders, right? And remember that if you have a subtraction there, then change the order, you have to be careful. You have to carry around the signs as well. Come back to this. So we have s equals a plus d all the way to a plus 99d. And s also equals a plus 99d plus a plus 98d and all the way to a. Now, next is the technique of taking those two equations and add them together. So left equals s plus s, which is 2s, equals, and when I'm doing the sum, instead of taking this order of a plus d, I'm going to take in the order of doing as pairs. This is sum, this is sum, this sum, and this sum, this sum, and this sum. Again, because summation is commutative, so the ordering of doing the sum of all those 200 terms does not really matter. So here I'm doing this term, these two terms together, these two terms together, these two terms together. Okay? As if you are putting a parenthesis on these two terms, taking them out, doing that sum first. So when you're adding these two terms, this equals 2a plus 99d. These two terms, 2a plus 99d. Wow, you see, they actually add up always the same thing, 2a plus 99d. The last three terms, all the same, 2a plus 99d. Okay, and how many such 2a plus 99d's? It's going to be 100. And of course, this sum is like we're adding 100, like the same term together. So it's 100 times 2a plus 99d. Okay, and remember this is 2s, okay? Double of the s. So s going to equal 50 times 2a plus 99d. Why is 50 now? Because I'm taking s equals 100 times 2a plus 99d divided by 2. So I'm 100 divided by 2 first, which is 50 times this. And this is the general form for doing summation of the first 100 terms for an arithmetic sequence starting with A, and the difference is D. Obviously, to calculate any number of terms, it's just a matter of changing this 50 to the general number n. So that's the first way. And actually, let's look at the second way. The second way is going to be interesting, as we're going to be using some known facts. Let's look at the second way. So remember that we want to calculate this S equals A plus D, second term, plus A plus 2D, plus the 100 term is A plus 99D. I'm making the mistake as well. Yeah, because the first term is A plus 0D, the second term is A plus 1D, so the 100 term is A plus 99D. Okay, pay attention to this, 99D. You don't want to add in another term. All right, so we're now going to be using the technique of reversing the orders of a summation and add them together, double the sum, and then you see the to do the pairing. Instead, S equals, you see for each of these terms, there's an A there, right? So I'm going to take those A's first. Again, it uses the property that for sums, the terms are commutative. So it does not really matter you adding one term first, adding another term first, you can change in order. So I'm going to change the order doing this. I'm going to adding all the A's together, getting all the A's out. And then I'm adding those D's next. This requires a little bit of explanation. So first, I'm extracting all the A's and adding them together. First, how many A's? Well, you say, that's pretty easy. Totally how many terms? Think about it. It's 100 terms, right? So this is 100A. A plus A plus A, 100A. And here, the D's. The first is a D, the second is a 2D, all the way to 99D. Okay? So we want to do this sum, which is easy, and we want to do this sum. Okay, let's first write down the first sum. It's 100 times A. That's easy. The second is we're using a distributive law. You see that every term has a D, D plus 2D plus 3D plus all the way to 99D. And this D is a common thing. And using distributive law, we can factor that out. We're going to take the D out. So inside will be equal 1 plus 2 plus 3 plus all the way to 99. Okay? So here's 100A. Now for this D, and this 1 plus 2 plus 299. All right, how you calculate that? Well, that we already talked about in one of the lecture. I'm going to just write it down. This equals 99 times 100 divided by 2. Or I'm going to write down 100A plus D times 99 times 50, because 100 divided by 2 is 50. Okay? And we use the fact that 1 plus 2 plus 3 plus 4 plus all the way to 99 equals 99 times 100 divided by 2. Or in general, 1 plus 2 plus 3 plus 4 plus all the way to any n is an integer number. This equals n times n plus 1 divided by 2. And we're going to be using this quite a lot in our math problems. And the proof that is actually pretty easy. One way is, again, using the pairs them together, 1 plus n, 2 plus n minus 1, and so on. Okay, we're not going to go into detail of that, but this is something that we should know by now. That's it.